Well, hello, friends. Welcome back to Commute Talk. Today, I'm taking a little break from programming, for a few days, because what happened? What happened was that a good friend of mine told me that, well, Andreas, I think that you're not really doing anything but programming for quite a while now, and I'm a little bit worried about you. And you could tell that they were right because my reaction was immediately like, "You can't tell me what to do. I can program all that I want." And I got all emotional and weird. So I got to calm down a little bit. Um, it's good to have friends who tell you when you're going too far. Um, but that doesn't mean I can't talk about programming in the car. And so here we are. Anyways, so today I thought I would talk a little bit about this old saying that unused RAM is wasted RAM, because somebody asked me about that yesterday, and so that's something that you hear a lot, and I've especially seen it when people are discussing the Chrome browser, which I think is an interesting situation to bring that up. So, I mean, my short answer on the whole saying, or my short comment on it, is that it's more nuanced than that, and I think that it's not as simplistic as the saying would have you believe. So, yes, unused RAM is wasted RAM, but in a traditional desktop operating system environment, for instance, there's more than one app running, right? And so applications are sort of expected to be good citizens and share the resources. And so any one program that decides that he's the most important and just starts gobbling up all the resources that he can get, that's not necessarily a great citizen. Now, on something like a game console, like if you're a PlayStation game and you just allocate all the memory that you can, that makes perfect sense because you're the only thing running, and it's completely unambiguously obvious that the user only cares about your process, your game process, right? But if you're a browser, for instance, then the user might also have Photoshop running, or Microsoft Word, or an IM client or whatever, and it's not cool to soak up all of the available RAM. So I think the idea that unused RAM is wasted RAM is true, but that doesn't mean that you should sponge everything that you can. And so I think this is a problem that is very, very far from being solved or even properly explored. It's not something that is a priority at the places where I've worked. And memory is something that I personally care about a lot because it's this overlooked metric, or like secondary metric. Like, people care so much more about speed, like how long does something take, or how much can you do at the same time, that type of stuff. But how much memory does it use gets less attention. So traditionally, I think the way that your average operating system behaves, like all modern operating systems, as far as I know, maintain a disk cache among other caches to speed up access to things. So that, like, say that I'm building something, right? Like compiling a bunch of C files. Then the second time that I invoke the compiler binary will be in the disk cache because I already loaded it previously. That type of thing. And since that happens in the kernel, then the kernel knows exactly how much memory is available to it. And whenever an application wants some of that memory instead, then the kernel is happy to give up some of its disk cache. I mean, I'm simplifying, but that's essentially how that works, right? And I think that's an example of a good citizen cache, but it mostly works because the kernel has all the information available to it to implement that. in user space, it's much more difficult because say that you're a big app that uses a lot of caches. Um, Even if you wanted to be a good citizen and yield the space, it's not at all obvious how to do that, or when, um, or how much, because there's, I think there's a strong need for user space APIs for this kind of thing. And this is something that I worked on a lot at Apple for WebKit and the Safari browsers. And we had a few different approaches to it, and they were very far from perfect. And they could have been better integrated with the system. But most of the approaches that we were using were based on watermark levels, so that processes would get notifications when they hit certain megabyte marks, basically in their footprint, and then we would react to those by switching into different memory consumption strategies or modes or whatever. So we would have I think they were called normal, conservative, and strict. Those were the names I came up with. And in normal mode, you're just operating, willy-nilly, right? Like allocating whatever you need whenever you need it. And then when you get told by the system, hey, you're getting a little big, or if the system tells you, hey, the system as a whole is getting a little big, we're together, you all are getting too big, then we would go into a conservative mode where we maybe don't cache as aggressively. It was a whole multitude of things that were affected by this mode parameter. But I definitely think that the idea is pretty good, but it could be so much better, and it could be so much wider across the system. And that's definitely something that I'm going to be doing for Serenity eventually. So unused RAM is wasted RAM, but an egotistical app that hogs all the memory for itself, that's also wasted RAM once it becomes a problem for everyone else on the system. And it's a sad thing because the kernel has very few ways out when it comes to a user space application getting too big, right? Because there are a few tricks that it can do. It can say, oh, well, you're not even using all of these pages that you've allocated. I'm just going to swap them out to disk. Of course, then it becomes extremely painful if you ever want to use those pages and you want to page them back in. Or you might skip swapping to disk but do a compression instead, which is more common these days, that you would run some, some deflate or whatever on the memory pages, and maybe reduce the number of pages used. And that's something that the kernel can do as well. But other than that, if it wants to keep the process running, the kernel is a little bit powerless there, and essentially has to give up some of his own caches, which is sad. So Darwin has a nice mechanism for this, which we used extensively in WebKit, and in other parts of the system as well. I shouldn't say it's extensively used in WebKit, but it's indirectly extensively used by WebKit because many parts in the system use it. So, and it's called Purgable memory. And if you don't know about that, then the idea is that you allocate pages from the kernel, and then those pages have a flag, which is called the volatile flag. And so if you mark one of those pages volatile, then the kernel can take it away from you at any time without warning you. And then if you ever want to use the memory in those pages, first, before you use it, before you access it, you have to mark them as non-volatile, and then you can access them. And when you mark them as non-volatile, you may discover that that they've been taken away from you, and then you have to regenerate whatever was in those pages. And I think that's super, super neat, because it gives the kernel a way to identify memory that is technically used by the user process, but the user process is willing to let go of, with no with no need to do anything to it first. Like, you can just yank it away from him, and that's definitely a mechanism that I would like to build as well. And I think that it's a mechanism that can also be improved upon, because you can build more sophisticated strategies for how to like which pages to take, which ones to leave alone. But the general idea, I think, is amazing. And so I guess what I think about this really, and what I would like to do myself, is I think that you must look at this in a much more holistic way, and you can't just look at a single process and say, well, if he's not using all the RAM that he can, then he's wasting that RAM. I think that's just not true if you're participating in a desktop environment. Yeah, that's what I think. And so, in practical terms, we need APIs for user space processes to understand their role in society, in app society, and but probably we also need policies, maybe some kind of declarative policies that say, like, well, this application is a so-and-so process, and being a so-and-so process, it's unreasonable for you to allocate more than this much memory. It's unreasonable for you to do this or that. And you would end up with something a lot like Jetsam on iOS, which is the mechanism that kills resource hoggers, or like tries to wrangle them, control them. Which I think that's a really good mechanism, and I would like to have something similar, because cooperation is very important. Like, cooperating between the kernel and the processes and each other, probably with the kernel as a mediator. I think that's how you can do a really good job with this type of thing. Yeah. Anyways, those are my unstructured thoughts about that. So I hope that answers the question of what do I think about unused RAM is wasted RAM. I guess I should also say that like, even if you're fully using all of the RAM, if you're filling it with ineffective or like inefficient data structures, or like excessive data structures, or duplicated data, then I'd say you're still wasting it. And you're actually hurting the system by doing that, right? Because if you can use less of it to achieve the same thing, you're still wasting that RAM, because you're taking it away from someone else who could be using it. And even if there was no user space app that would use it, the kernel would put something in there too, you know? So unused RAM is wasted RAM, but that's not an excuse to have inefficient data structures or duplicated data structures. And I guess that's how I often see it justified. The people talking about, like, oh, the new Chrome browser uses this much memory per tab, and people just blanket brush that off, saying, like, well, yeah, but unused RAM is wasted RAM, and there's very little consideration for what's actually in that RAM, and like, was there someone else who could have made use of that? Anyways, I guess that's that. So I'm just gonna say thanks for hanging out with me on the commute, and I'll see you soon. Bye.